Welcome to our next lesson in this introductory module. We're going to continue with our series on what money is worth. Present value, net present value, the internal rate of return, and the discount rate, or the weighted average cost of capital in this lesson. And specifically, we're going to be looking at the IRR versus the discount rate here. Once again, I'll give my standard disclaimer. You can certainly look at the written guide, go to method number 2 for making investment decisions, the internal rate of return, and we cover everything that we go through in this video there, but we do it in written format instead. So if you learn better by reading, you can certainly look at that. We'll divide this lesson into 3 main parts, and first briefly review the methods used to make investment decisions. Then you'll learn how to calculate and use the internal rate of return, or IRR, and then you'll learn how both evaluation methods for investments are actually the same if you think about the math behind them. In terms of making investment decisions, we learned last time around how you can compare an asset or company's intrinsic value to its asking price, and you invest if the asking price is less than the intrinsic value, which you normally calculate by taking the present value of cash flows discounted at the appropriate discount rate, which represents your opportunity cost. The second method is to compare the potential returns from an investment to the opportunity cost. And you invest when the potential returns exceed the opportunity cost. And we are going to be focused on method number 2 in this lesson. At the end, I'm also going to show you the math behind why both of these methods are actually the same, and how if their potential returns exceed the opportunity cost, that also tells you something about the asking price and the intrinsic value. So let's go to part 2 and learn how to calculate and use the IRR. The IRR stands for internal rate of return, and it's another type of discount rate similar to WACC, the weighted average cost of capital, except when you use WACC, it's normally something that you know or something that you've calculated based on similar companies or just based on this company's history and operations, but you solve for the IRR. So they're two different things. WACC is what you're expecting or what you're targeting, and then IRR is what you anticipate actually receiving or getting out of the investment. A more formal definition is that the IRR is the discount rate at which the net present value of an investment is 0. And we'll look at where that comes from and how that plays into all this in a little bit. When you have a series of cash flows and the discount rate, you can use that to get to the present value of the asset or company. And you saw an example of how to do that in the last lesson. But when you have the upfront investment or the asking price and a series of cash flows, you can get to the IRR, the internal rate of return from that. And then you can look at this IRR and compare it to the discount rate. And so you can use these concepts together. Now, to calculate this in Excel, there are a couple of things you need to know. First off, you almost always want to use the IRR or XIRR function to calculate this figure. IRR is a polynomial function, which means that except for very, very simple cases, there's no easy way to manually calculate it yourself. So you really need to use the built-in functions for this one. XIRR is useful if the cash flows arrive on irregular dates. So if they're not just 1 year apart in each case, but if they arrive 3 months apart and then 9 months after that, and then a month after that, and then 3 years after that. So if the cash flows arrive on irregular non-annual dates, then the XIRR function is useful. When you do this in Excel, upfront investments and contributions to the investment must be negative and cash flows earned must be positive. And if nothing happens in a given year, then you must enter 0. So let's take a look at what this looks like in Excel. If you go to the section, the internal rate of return and how to use it, for the asking price, we'll say 200. We're still using the same example of the apartment in Korea. We'll say 12,000 for the annual cash flow from rent. And then for the apartment sale value, we'll say 200. And then for the opportunity cost, we'll just go up and link to what we found up here for our opportunity cost or discount rate. Then to actually calculate the IRR, remember, we need to enter the initial amount that we pay as a negative number in Excel. So we'll link to this asking price. We'll use a negative sign in front of it. And so we end up with negative 200 there. We can add up everything in year 0, which is when this investment first takes place. Then for the rental income, we'll link to this annual cash flow each year. And then for the property purchase or sale, we're not going to have anything in years 1, 2, 3, or 4, but we will sell this property at the end in year 5, as we've been assuming all along, for $200,000. Now, of course, in real life, this is not exactly realistic because most likely the rent would go up each year and the property's value would probably increase by the end. So it would probably be more than 200,000 and the rent each year would probably be more than 12,000, but we're just trying to keep things simple here. So let's copy all these across. And then for the internal rate of return, we'll use the IRR function here because we're assuming that there is 1 year between all of these. And so we get to 6%. To make an investment decision, we compare this internal rate of return, our potential returns, to our opportunity cost, the discount rate or the weighted average cost of capital. And if the IRR exceeds our discount rate, we say yes, we invest. Otherwise, we say no. And that is pretty much all there is to it. Now, I mentioned this point about if nothing happens, you have to enter 0. As an example of why this is important, let's say that we just do not get rental income for the first 2 years. If we just delete that, the IRR remains at 6%, even though it doesn't really make any sense. We have less cash flow now, so the IRR should actually be less than 6%. To fix that, if we manually enter zeros right here, now we can see that we get to an IRR of 3.5%, which is a lot more realistic. We don't have that cash flow anymore, so the IRR must go down in this case. And that's just a quick example of why it's so important to enter zeros when nothing happens, to indicate to Excel that you are getting no cash flows and contributing no cash flows in those years. As I mentioned, manual calculations for this one are not really an option unless it's a really, really simple scenario, such as buying something, holding it, getting no cash flows in between, and then selling it at the end. For example, if you invest 100 and you receive back 200, you could calculate the IRR using this formula. If we go into Excel and enter this, 200 divided by 100 raised to the power of 1/5 minus 1, we get to an IRR of around 15%, 14.9% to be more precise. And so if it's something very, very simple like that, where you literally put in 100, you get nothing in year 1, nothing in year 2, nothing in year 3, nothing in year 4, and then 200 at the end, then yes, in a very, very simple case like this, you don't need to use the IRR function. You could just calculate it manually with this formula. As I mentioned before, the WACC is the discount rate that you're targeting or expecting, and it really represents your opportunity cost, what you could earn by investing in other similar companies or assets elsewhere. The IRR is what you think you'll actually receive, the potential returns. So they're similar rates, but one is expectation, and then one is what is actually going to happen. And so you're measuring the anticipated results against your targeted results. One way to think about the IRR is that it's like the effective compounded interest rate on an investment. So if we were to invest the $200,000 that we showed before and we earn 6% on it each year, because that's our IRR in this case, and we compound it annually, we get the equivalent of the cash flows shown here. If we have 200,000 here in the beginning, we take this and we multiply by 1 plus the internal rate of return right there. And we copy this across. By the end, we get up to around 267,000. So this should be sort of equivalent to what we get in terms of cash flows in years 1 through 5 here. Now you can see it's not exactly equivalent because we get 260,000 there, whereas we get 267,000 here. The reason that happens is because of the timing differences. We get a lot of cash flows in between in years 1 through 4. And so these cash flows that arrive earlier on are actually worth more, which is why these numbers don't quite match up. It's easier to understand this point and to see this point if you look at something very simple, like this example here, where you put in 100 and you get back 200 at the very end. Because with this one, for example, if we have 100 in the beginning, and then we multiply by 1 plus the IRR right there, you can see that we get to 200 by the end. So we have 100 in the beginning, we earn about 15% interest on it. That compounds, so our principal goes up. We earn another 15% interest, and it keeps going like that until the end, until we get to the 200 at the very end. So that works for very simple scenarios, but it doesn't work when you have these cash flows in between. Another way to interpret the IRR is that it's the discount rate at which the NPV equals 0. NPV is the present value of cash flows minus the asking price. So to set this up, we can just link to our rental income from above. For the property sale number, I'll just link up here. And so we get to our net cash flows down there. And then to calculate the NPV, we can just go up and use our IRR for the discount rate, apply it to these net cash flows, and then we can subtract our asking price right up here, and we can see it comes out to almost exactly 0, which shows how the IRR is the discount rate at which the NPV of an investment is 0. So those are a few different ways that you can interpret this. In short, with method number 2, you compare your potential returns to the opportunity cost. This method is useful when you know the cash flows and you know the asking price of an investment, and you also know what you could earn elsewhere, in other words, the discount rate. You can calculate the IRR based on the cash flows and the asking price. The asking price will be shown with a negative in the beginning. The cash flows will be positive after that. If you have to contribute more to the investment, that'll also be a negative. If you sell the investment, that'll be a positive. If the IRR exceeds WACC, then you should invest because it means you have a positive net present value. And if the IRR is less than WACC, then you want to stay away. The net present value is negative, and it means that the potential returns are less than your opportunity cost, so you could do better elsewhere. That's a bit about how to calculate and use the IRR. Let's now go to the last point and talk about why both evaluation methods are the same. You should already know that net present value equals the present value of cash flows discounted at WACC minus the asking price of an investment. If the NPV is positive, you invest because the present value is greater than the asking price. By definition, if the left-hand side of this is positive, then the positive component must be greater than the negative component here. Now, you also know that the IRR is the discount rate at which the NPV equals 0. If the NPV up here equals 0, then the present value of cash flows discounted at WACC must equal the asking price. According to this definition of IRR, 0 is the NPV when you discount the cash flows at IRR, and then you subtract the asking price. So present value of cash flows discounted at IRR minus the asking price is 0 according to this definition for IRR above. Now, the asking price and the cash flows are constant in both formulas. So if you look at the formula for normal NPV here, and if you assume it's positive, for example, and then if you look at the formula involving IRR and what it means, the asking price is the same exact number in both, and the cash flows are also the same. Now, the present value is not the same because they're discounted at different rates, but the cash flows and the asking price are the same. What this means is that we have two equations with constants and two variables that we have to solve for. So if we say that x equals the present value of cash flows discounted at WACC minus the asking price, where x is greater than 0 because we're assuming the NPV is positive in this case, and if we also know that 0 equals the present value of cash flows discounted at IRR minus the asking price, we know that a lower discount rate produces higher present values. What this means, if you think about it, is that the present value of cash flows discounted at WACC must be greater than the present value of cash flows discounted at IRR. Therefore, WACC must be less than IRR, because if this term is greater, then WACC must be a lower number because a lower discount rate produces higher present values. So if the NPV is positive, then the IRR exceeds WACC. And if the NPV is negative, then IRR is less than WACC. So that's the basic thinking for how this scenario works and why these formulations are really saying the same thing. Which one you use comes down to the information you have. In some cases, IRR will be more useful if you know the cash flows and the asking price, for example. In other cases, the present value will be more useful if you have a better sense for the discount rate and the cash flows, but maybe you're not certain of the asking price, for example. Let's do a quick recap and summary. In part 1, we went through how to make investment decisions, compare the present value of a series of cash flows to the asking price, or look at the potential returns and compare it to the opportunity cost. If the asking price is below the present value, you want to invest, and if the potential returns exceed the opportunity cost, you also want to invest. You learned how to calculate and use the IRR using the built-in Excel function, which is highly recommended in this case, and how to interpret it. You can think of it as the effective compounded interest rate on an investment. It's also technically the discount rate at which the net present value of an investment equals 0. And then you saw why both evaluation methods, present value versus asking price, and potential returns versus opportunity cost, are actually the same thing, and how, for example, if the present value exceeds the asking price, meaning the NPV is positive, then the IRR must exceed WACC, and vice versa if the opposite happens. So that's it for this lesson. Coming up next, we're going to go through a simple exercise based on these concepts, and you'll learn how to apply them if you're working at a company deciding on expansion projects.